and you check the value of x, and you check the value of y, right?
Yeah.
Makes sense.
But the only problem with that, it would only work for numbers that are not decimals. That's the main problem with it. Because if it's decimal, it's really difficult to actually find out exactly what's the answer.
Yeah. You know, I told you in Nigeria, most of these graphs were taught using a computer. Because hardly will you find computer in any schools. Most of the schools, they don't use computer.
Yeah.
But if you graph, yeah, it's going to make sense. Okay. Now we have this joint variation. We've talked about direct variation. We've talked about inverse variation, and we have joint variation. Joint variation is the combination of the two. Now, for example, you have A varies directly as B, and inversely proportional to C. So, and here we have A varies directly as B, and inversely as what? C. So here we can have A equals to KB over C. Okay? KB over C. So you can have something like this. Now we're having three quantities. If you want to do this, to get a constant term, you're going to be given the three quantities, you get a constant. And if you are asked to get any of the other two quantities, you can have one. But one problem with this joint variation is that most times it leads to simultaneous equation. Most times, yeah. Because in most cases, after you've gotten your constant k, you'll be given just one value. And then you have another problem, you have another value, then you have to solve for the two unknown values. So that's the problem with joint variation. The second problem with joint variation is that sometimes the way it is being structured, you can be told that, okay, A varies directly as square root of B and inversely proportional as the cube of C. So you have to think on how to break it down. That's why the basic algebra is the father of everything. If you understand how to solve basic algebra, then everything is done. Questions on this? No. Let's see some examples. This is what we're going to do. We're going to do 3 examples on this. First, we look at simple examples, then you go to the last. I think the way they structured mathematics problem is that they start with simple examples and they proceed to something tough. Yes. This is not charging. So that is where our mathematics is being structured. So, and that is the same thing we're going to do. Now, to do this, okay, let me just write this somewhere here. We have A varies directly as this. So we have A equals to KB over C. Now, let's look at the first example we have. So here we have example 1. So read.
The volume of a right circular cylinder varies jointly as the square of its radius. And
wait, I'm writing that. You're too fast.
The volume of a right circular cylinder.
Right, yeah. Right circular
cylinder
varies
jointly as the square of its radius.
The square of its radius.
And its height.
And?
Yeah.
Its height. Just height?
Height, yeah. Okay. And then the second sentence, a right circular...
This has full stop, right?
Yeah.
Okay.
A right circular cylinder with a 3 centimeter radius.
Circular cylinder.
With a 3 centimeter...
With a 3 centimeter...
Radius.
And the height?
of 4 centimeters.
And the height
Of 4.
4.
Yeah.
This first is a right circular cylinder with a 3 centimeter radius and the height of 4
Centimeters.
centimeters. Okay,
Has a volume of 36 pi.
and the volume of
36
pi.
pi, yeah.
Okay,
Cubic centimeters.
okay.
Find the volume of a formula for the volume of a right.
Find the formula.
Yeah.
Okay,
Of a right circular cylinder.
of the right
Circular cylinder in terms of its radius.
circular cylinder in terms
Of its radius and height.
of its radius and height. Yeah, that's one problem with this joint variation. It is almost, the problem is very much wordy. Now, answers. Now you have to break this down. So what are the 3 things we have? We have 3 parameters there. The first is we have the volume,
The radius.
we have the radius, and we have the height. So we have 3 things. So here you can just say let. Sometimes in an exam you have to let your professor know. Let V represent the volume. Let
R.
R represent the radius. And then let H represent the height. So those are the 3 things we have. Now, it says the volume of a right circular cylinder varies jointly as the square of its radius and its height. Now, looking at this, varies jointly. We don't know. Do we have direct variation first? Do we have, let me break this down. Do we have direct variation? Do we have inverse variation? Varies jointly. So what do we do?
So they have both inverse and direct.
Both inverse and direct. Do you have an example there?
They have what?
Any example over there to show? Do you have an example that that partition it into 2?
That's the question. No, there
Let me
is.
see.
There's the buffer zone variation.
Where's the example you gave to me now?
And this one.
Okay, this is what I would have expected you to give me first. You have direct and you have inverse, you understand? But don't worry, we're going to do this. So you should have been from the simple then to something more tough. So you should have given me this first, and then we move to this 54. But don't worry, we're going to do this. Now, so here we have joint variation. So it varies jointly as what? R squared. And what? The height. Okay? Here you have 2 things. So the other example I gave to you is you can be told you have direct and you have inverse variation. But here we have joint, which is 2 things simultaneously. Okay? Now, good. And the height cylinder. Okay, now we have full stop, right? A right circular cylinder with a 3 centimeter radius. So here we're going to have V equals to K R squared H. Okay? We have 3 centimeter radius. K dot radius is 3, let me use times, squared. And the height of 4 centimeter times height, which is what? 4. And the volume is what? 36 pi. So what is going to be the K? So here we have 36 pi equals to 3 squared is what?
9
Times 4.
36
36k. So what is k?
pi.
Pi. Yeah, k is pi. So now the question now proceeds by saying, find the formula of a right circular cylinder in terms of its radius and height. Find the formula of a right circular cylinder. Okay, find the formula of a right circular cylinder. Do you mean the volume? I think the formula for the volume of a right circular cylinder. Check. I think find the formula.
Yeah, find out for the volume of
volume. Okay. Now V is now going to be K, which is pi R square H. So this is the formula, pi R square H. What is the formula for a circle? Volume of a circle, yeah.
Pi r multiplied by r squared.
Yeah, it should be
So that's a cylinder. You multiply how much this, like the base is by its height.
Because the unit should be in cube, and this is in centimeter square, centimeter to the centimeter cube. So this is the formula. Cool. Do you understand?
Yes. Yeah.
Take the picture, please. Okay. Now, I want you to look at this carefully if you have any question. So the first example you're going to give it to me right now. The first example. So I want us to solve something related to combination of the two. Now, can I clean this?
Yeah.
Okay. Now, example 2.
And the number of men
The number of men
represented by y
represented by y
needed to lay a cobblestone
to lay stones
is directly proportional
is directly proportional
to the area A.
Okay, to the area
And it's represented by A.
A.
Of the driveway.
All the driveway.
Of the driveway, yeah.
Continue, don't worry.
Of the drive and inversely proportional.
And inversely
Proportional to the amount of time.
proportional to the amount
Amount of time.
of time.
T.
T.
Typically 3 men
Okay. 3 men. I'm trying to shorten it.
can lay 1,200 square feet of stone.
Can lay 1,200 square feet.
Yeah,
Square feet
of stone
of stones
in 4 hours.
in 4 hours.
How many men
How many men
is needed
is needed
for 2,400
for
square feet
2,400 square feet
of stone
of stones
in 6 hours?
in 6 hours? Try this. Write something down. Get a pencil. I want you to try this. Okay, you have a pencil already. Try this and let's see. So here we have two things. We have the direct proportionality. We have the.
I got the answer.
You got the answer?
Yeah.
So what's the answer?
4.
4. What about you? I'm wondering how you got the answer so fast.
It's difficult. I just divided 1,200
You
by
got
4.
4. Don't worry, you got 4, right?
Yeah.
You got 4. Okay, we have the first answer to the 4. What about you? I'm gonna wait for you, don't worry. Let me start reading, man.
Is that 1,260 or 50?
This is 1,200.
Okay.
And this is 2,400. I'm trying to see. Sometimes, if I'm solving simple questions, you will see in the comment section people putting the answers there. But when you're trying to do something that requires time, you hardly find people with comments. Everybody loves simple maths. Now, you done? But I doubt if the answer is going to be 4. But possibly it can.
No, I got 4.5.
4.5.
Yeah, just get a child with
And there's a question here. Statistically, if you get 4.2,
You can have 0.2 men.
so what's going to be the answer?
5.
4 men and 1 kid.
If you have-
We didn't know how much.
Okay, 5.
okay.
5 men, yeah.
What is the difference between you having 4.5 and 4.2 men? If you want to,
Nothing, because he have at 20% of a man.
yeah, you have to know this. When you're talking about living things, okay, when you have even 4.002, it's going to be 5. You round up, you don't round down, okay, because you don't have half men. Even if you're handicapped, you are still a human being, so you should know that. Now let's do this. Okay, it says the number y.
Can I change my answer? I want to be 6.
Okay, agreed. 6. Okay, y varies directly as area, and inversely as what? The amount of time. So y equals to k a over t. So now we have 3 men. Okay, men is y is 3 equals to k times the area is 1,200 and the hours is 4. So here we have, if you cross multiply, we have 12 equals to k times 1,200 divided by 12 divided by 12. K is going to be
No, isn't divided by 1,200?
1,200, 1,200. K is going to be 1 over 100. That's K. K is going to be 1 over 100. Now, secondly, we want to see how many men. So here we have K times is needed for 2,400 in 6 hours. And here we have 6 here 1, 6 here 400. And K is 1 over 100 itself times 400. So Y is going to be 4 men. How did you get 6?
So I divided 1,200 by 4,
Mm-hmm.
which is the amount of hours, to get 300. So 3 men can get 300 stones in 1 hour. Dividing it by 3, so each man can get 100. And then you multiply, and then 2,400, which is the goal, divided by 6. So you need 24 hours for 1 man. 24 hours divided by 6, because you can have 6 hours, is...
Do you know the method you used? Yeah, I understand what you did, but sometimes the method you used can be confusing. What if you are having just joint variation, not inverse? going to be confusing. So it's better you follow the formula. Sometimes when you do it yourself, I mean using your own method, it's going to work. Yeah, fine. 1,200 over 4, like what you did here. If I divide this by 4, I'm going to have 300, right?
It's just the same thing. This is just to do it without actually writing.
300 over 3, you still have 1 over 100, which is still the same. But here you're having 100.
Because I did it instead, k multiplied by the thing. Since I haven't k in the top, I did k in the bottom. So you can divide it by 100 instead of multiplying it by 1 over 100. That's...
No. Actually, you got the answer right, but, you know, if the professor wants to grade, you flip it. So here too, you're going to flip it. So it's going to be confusing. And then sometimes in mathematics, there's a slogan we used to say, we don't mark the final answer, we mark the steps. If your steps is not straightforward, you don't get any marks for the final answers. Use the formula. With formula, everything is easy. Yeah. Let's do one more. Yeah. Go to the last question. I think that one should be tough. Take the picture of this. So, what do you do? Why do you get 6?
Huh? Oh no, I did something wrong.
Okay, example 3.
I think I should do like the fourth to last one, because that one has numbers. The other one is just like you have to write the formula instead of like right.
Yeah, writing the formulas too can be technical. I mean, it should be tough like that.
Because like I mean, you won't be able to find any numbers in it.
Yeah,
It's just not.
it makes sense.
Let
me check.
Yeah, because I think like
if y varies as the square of x and inversely square of t, then how does y change if both x and t are doubled? Ooh, I love this. Makes sense. You have to do it. I don't want you to face the camera, but I want you to try it. Okay, read.
if y varies directly
If y varies directly
as the square of x
as the square of x
and inversely
and inversely
as the square of t,
as the square of t. T, right?
yeah. Then how does y change if both x and t are doubled?
If both x and t are doubled. Let me give you 3 or 4 minutes to do it. I want you to do it step by step. If y varies directly as the square of x and inversely as the square of t, then how does y change if both x and t are doubled? I'm giving you 3 minutes. Think about it. Save the time.
I think it's too simple for that. I think I got my answer. Just y equals x squared divided by t
y
squared.
equals
X squared over what? T squared.
over t squared. That's your answer, right?
Yep.
You have 2 more minutes to do it. Take your time, Manu.
Okay, I think
You've done it too?
Let me see. I think that's y equals k x squared over t squared.
Let's see. Okay. It says if y varies directly as the square of x and inversely as the square of t. Let's do this. Y is going to be k x squared over t squared. What is k? Your k is going to be yt squared over x squared. Okay? Look up, look up. This is k, right? Now the question says, let's rewrite this equation again. We have y equals to kx squared over t squared. This is the most important equation we always have. Now the question is then, how does y change if both x and y are doubled? What is the meaning of double?
Times 2.
Times 2, right? So what happens to y if both x and y are doubled?
K.
So here we have k, right? What is x? We have 2x now. And here we have what?
Tx, 2x, 2t.
2y.
Y or t?
2t rather, sorry. 2t. Which is, and my k is yt squared. We even have y, yeah, y. Yt squared over x squared multiplied by 4x squared over what? 4t squared. Okay?
Mhm.
Even if you square this, this is still cancelled.
Uh-huh.
Here, x squared is going to cancel x squared here.
Mhm.
T squared is going to cancel t squared here.
Mhm.
So y remain the same.
So I'm right.
Y remain the same. Nothing is changing.
Yeah.
Y is not changing.
Yeah.
You got it wrong. Y is not changing. Even here,
No,
if
so
you
like,
plug in, if you double t here, you have 4t
Yeah.
squared, 4x squared. It's still going to be the same. Questions?
so look, you said y equals k x squared over t, right? That equals y.
Yeah, this is y. This is this is the given. If you interpret this first sentence,
Mhm.
this is what you have. And anytime you are given this equation, what you need to do is make k the subject of the formula. If you look at the previous example we did, we got a value for k. So you will now plug in the constant back into the given equation based on the new value given to the variables you have. So this is what we got for k. So you plug in back into this given equation and you have this.
Yeah. And knowing that y is not gonna change, so I gave you the same formula as before. So that's what happened.
But what you just want to see is how does y change? But here y is not changing.
Yeah.
Y is not changing. So even if you want to put 2, your t doubled, your x doubled there, still going to cancel out, you still have y. Y is not changing. You have questions?
I understand it, but like it's kind of confusing.
Yeah, okay. What's confusing?
Why it works?
Why? Do you have another? I mean, if you have another question, we can do it. If it looks almost the same. So why is not changing? Nothing is going to happen to y. It's going to be the same. You have another one? Do you have the answer over there?
Yeah, I do, and it
Okay,
says
okay,
also
okay.
says remains unchanged.
So why remain unchanged? It's not changing. So let's do one more. Let's do one more.
I have a question.
Oh, you should have taken the picture. I forgot.
I have a question over here.
Okay. Just on variation or inverse. What kind of example 5, right? Yeah, read.
The variables p varies directly.
The variable p
Yeah, varies directly
varies directly
as the cube of a.
as the cube of a,
And inversely as the cube of b.
and inversely
It's just the same question.
as the cube.
That makes the same question. How does p change?
Yeah.
Yeah, it's the same question.
Almost the same thing.
Yeah.
So I mean, this kind of question you can see, yeah. But yeah, how does p
no,
change,
wait,
right?
this is different.
How does p change?
How
Okay.
does B change if
B.
A is doubled and P is tripled?
This is change different. How does p, right,
Mm-hmm.
change?
No, like P, like the other P.
This p.
Yeah.
Yeah, this is
Oh, yeah.
it.
If A is doubled
If a is doubled,
and B is tripled.
b is tripled. Let me give you 3 minutes to do this.
It's not a race.
It is a race. It also stays unchanged.
Unchanged?
Yep.
Okay. What about you?
Yeah, I'm still going. Yeah, this is the same question in a way.
Okay, let me
It
go
doesn't
from
matter
home.
if it's doubled, tripled, it is still gonna be the same thing.
Muhammad? Don't be shy to BT, please.
No, I'm not using. I'm not using. I'm not using.
Let me wait for you. Let's see. Unchanged. I think something is going to happen.
Yeah, I think so too. That's the thing.
It should.
It should.
I think so. I'm not sure. Let's wait for me.
Not changed. Didn't change it.
Are you sure?
Yes.
Again, are you sure?
Yes.
Okay, let's see. P varies directly as the cube of A, inversely as the cube of B. So here we have P equals K A cube over B cube. Right? What is
I
K?
thought like the area of the cube is A.
as the cube of A and inversely as the cube of B. Right? We're not talking about the area here. So here, K is going to be B cube P over A cube. This is K. Now, let's go back. P equals to K A cube over B cube. This is what we have here. And it says, how does P change if A is doubled? That is, A is doubled. And P is tripled. So what happened? So here we have P. In fact,
we have A cubed and then
don't let me do it this way. Let me write what K is. K is B cube P over A cube multiply by A cube over what? B cube. Right? So we have B to be tripled. 3B cube times P. And A is doubled. 2A cube. Multiply by 2A cube over what?
3B cube.
So, sorry, should be outside. So this can cancel out this. And this can cancel out this. So P is still P, unchanged.
Look, that's why the machine answer.
Oh, it doesn't change?
Not really.
Initially you told me unchanged, but
Yeah.
you changed your mind.
I changed my mind. So the way I did it, I thought I was gonna do is because 3 times 3 is 9, and this is it's out.
Even 3 to the power of 3 is minus 7. Not
Mhm.
right.
Yeah.
So initially I thought it's going to change too, but it shouldn't.
I think no matter what you multiply by, even if you multiply B by like 20 billion.
Because
It's
the
still
way
the same
you're
thing.
constant. Because of the K.
Yeah.
Because of the K.
The K makes them cancel out no matter what.
Okay. Let's look for. Let me just give you one question and we end it. Not on variation. I think we've done on variation. Yeah. I was teaching a math trick sometimes. Like multiplication math trick for table 9. You know the trick?
What trick? There's
Yeah,
multiple
those
tricks.
like you mean like the 90 ones?
No, not
Table
times
nine,
1.
table
Table 9, 9 times 1, 9 times 2, 9 times 3.
Oh, you just
Nine times
make
four.
30 minus 3, like 40 minus 4.
No. 9 times 5, 9 times 6, 9 times 7, 9 times 8, 9 times 9, and 9 times 10.
So for me, I just multiply it by 10 and then subtract it by the original number.
Oh, you multiply by 10?
Yeah, like multiply the 2, for example. And 9 multiplied by 2. You multiply 2 by 10 to get 20, and then subtract it by 2 to get 18, which is the answer.
Makes sense.
Which works for all of them,
Example,
because it's 9,
This is the 30 minus 3, 27.
27. But like 9 multiplied by 9, 90 minus 9, 81.
You know, I'm learning new trick now.
And
Actually, I know 2. But now I'm learning something like 9 times 10 is 90 minus 9, 81.
Mm-hmm.
Okay. Yeah, I learned something new. But there's this, if you just want to do everything, just write 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
Yeah.
There's another one again I know. Is that okay?
You're adding one to that side and subtracting one from that side.
Don't let me forget. Okay, this is 9 times 5, right? Okay, this is it. This is, let's just pick 9 times 5. You are multiplying by 5, right?
Mhm.
Just subtract 1 from 5, which is 4. So what are you going to add to this to make 9?
5.
5. So 4 plus 5. If you look at addition of everything, it gives 9. Look at this. 9 times 8, right? Just take 1 out, which is 7. So what are you going to add to 7 to make 9? 2.
9.
So there's another one. So we have, I think, my YouTube short I've done for table 7. Table 7 is the most tricky one. Table 7, table 8, table 9, 10 does not need. Table 12, 13, 14, 15, 16, 17. I think I'm about to do table 19 too.
11 is an easy one.
That was pretty easy. That was pretty easy. But we have so many techniques. Now, let me just give you a question and then we can end the class for today. Let me think about a question. Are you ready?
Yeah.
It's going to be on algebra. It's going to be on algebra. It's going to be on algebra. We have 3 into bracket x plus 3 divided by x plus 2 minus 2 into bracket 3x minus 2 divided by x minus 2 equals to 0. Solve for x. You have to write it down. You can't think. You can't use your head to do this. You have to write something down.
Are we supposed to find x?
How are you supposed to find
Oh,
x?
no. Okay, خلاص. I was asking, we're supposed to find x, right?
Mm-hmm. I have a lot of things to do today. I have to write research, run some code, shoot some videos. Let me just give you an hint. This is going to lead to quadratic equation.
I felt like I wasn't gonna do that, but I didn't want to do that.
Interrompu na immortalidade dos humanos. So possibly you can get two values for x.
Yeah. Well, there should be. I forget what the quadratic formula was.
Minus b plus or minus b squared.
And what was the quadratic? very difficult. So I think the answer is either negative 8 over 10 or negative 10 over, or negative 1.
No square root?
No square root.
Are you sure?
Yeah, because it was 1, so 1 square root is just 1.
So in the square root you go on.
Yeah. So I just substitute inside just 1.
I'm waiting for you.
Okay. Just need to put it in.
Oh. Are you trying to plot it?
No, just calculate.
Work it out. Don't use calculator.
It's not difficult. Just now multiply by 81 minus.
Yeah,
4 eighths.
I did something wrong. It's not working.
You see? Maybe you have a negative in the fraction. So 9 minus 4. No, we don't.
Yeah, it's not working for me.
Next, yeah. You know this variable, right?
Yeah, obviously it's not gonna work. It's gonna have yeah, so it's gonna. I'm gonna have to work it out because I thought this. It's not gonna work out.
Might well.
It's gonna happen with real numbers and stuff.
If it's an imaginary number, just say it's undefined.
Mhm.
If it's I, just say it's undefined.
Yeah, well, both of them are undefined, so I can have that.
Then make it undefined.
I'm waiting for you.
Okay.
So we spend more than an hour today.
Yeah, I think if you probably want, because I just wrote it everywhere, basically.
Okay. Let's do this. So, what's the answer?
Negative 8 over 10, which is
Negative 8 over 10
yeah, or negative, or 1, positive 1.
or positive 1. So,
My answer was.
No, negative 1, negative 1.
negative 1.
Okay. My answer is x equals 3 plus or minus square roots of minus 182 and 183 over 6.
Over 6. Okay, let's see. Now, the first thing is find the LCM. And the LCM of this is going to be x plus 2, x minus 2. Right? So, this in this, you have this. So, you have 3, x plus 3, x minus 2, minus 2. This in this, you have this. It's like this is multiplying this. 3x minus 2, x plus 2 equals to 0. Right? So, here we have 3, x times x, we have x squared minus 2x plus 3x minus 6. You got that? Minus 2, 3x squared, right? 3x squared plus 6x minus 2x minus 4. Everything equals to 0 because if this cross multiply is going to be 0 automatically. So here we have 3x squared minus 6x plus 9x minus 18 minus 6x squared minus 12x plus 4x plus 8 equals to 0, right? Collection of like terms. 3x squared minus 6x squared, we have negative 3x squared. Minus 6x plus 9x is going to be
3.
plus 3. Plus 3 plus 4 plus 7 minus 12 minus 5x. Right? Am I correct?
I'm confused why you started.
This is like 9x plus 4 is 13. 13 minus 18 is negative 5. Minus 18 plus 8 minus 10 equals to 0. Divide through by negative, we have 3x squared plus 5x plus 10. Who got this equation? No.
I'm confused why did you have the starting 3 multiplied by x plus in parentheses x plus 3?
This?
No, the first one on top.
This?
Yeah.
Yes, you have to, because this 3 is multiplying these 2. So the first thing you have to do is, when you use PEMDAS or BODMAS, you have to remove the parentheses before multiplication.
Yeah, but why did you multiply x with parentheses?
Why didn't I multiply both?
No, why were you able to multiply them?
I only distribute. This is what I did. Use x to multiply the entire parentheses. And
No,
also
like,
use 3
because in the original equation it was like 3x minus that. Then you just... So how did you transform this into that?
This multiplying this. Okay, you mean how did I got this, right?
Yeah.
Yeah, how did you actually got...
Now, easy. This is the LCM of this. Whenever you multiply the LCM, okay, this is a shortcut. We have 2 ways of doing it. You can multiply this and you can multiply this. Provided you multiply the denominator to give this. Or alternatively, you can say this divided by this, you have this left. So use it to multiply this, which is this. So to make, for like example, I'm giving you 1 over 3 plus 1 over 2. Just multiply these 2, which is 6. Then you can do like this. 2 times 1 is 2. 3 times 1 is 3.
Yeah.
So this is what I just used. Now we have this equation. Now you can say, if I have 30, A is 3, B is 5, and C is 10. So now
Why didn't you go back and divide x plus 2 and x minus 2?
this.
Yeah.
Then I cross multiply. This is going to multiply 0, and it's going to make the right answer to be 0. You understand? So
Yeah.
that's why I make this to be 0. If it is 1, then you can multiply and have that. Well, it's going to be 0. So here you can have minus b plus or minus root b squared minus 4ac over 2a. So here we can have x equals to minus b is going to be negative 5 plus or minus b squared is going to be 5 squared minus 4ac. 4 times 3 times 10 over 2a. What is a? 2 times 3. So here we have x equals to minus 5 plus or minus root 5 squared is 25 minus 4 times 10 is 40 times 3
So 120.
120 over 6. Yeah, you have no solution. No real solution except you want to have complex number. So this is going to be 95, I think, negative 95 over 6. So you're going to have complex numbers. So no real solution for this problem.
If you could have a real solution with I, right?
Yeah, no, that's going to be a complex, not real. Complex number.
Yeah.
It's like you having square root of negative 4. It's going to be 2i, which is a complex number. So what I just wanted to know is, how do you, when you have something like this, how do you deal with it? If this is 1, then on the right hand side, you're going to have, this is going to be s squared minus 4. And then you can cross multiply and do one or two things. I mean, collect like terms. Questions? Yeah. So we can end the class for today. Okay?
Wait, one thing.
Yeah.
What about like if for like the first one is 3 and then parentheses x plus 3? Isn't if you distribute that's gonna be 3x plus 9, right?
This?
No, he's talking about the first one
This?
over here. Yeah, if you
Okay.
multiply the 3 to the inside.
The first thing you did was to distribute first, right?
Yeah.
Yes, you get the same thing. This is going to be 3x plus 9, right? 3x plus 9 multiplying this will still give you this. Give you this. If you try it, you get the same thing. Even if you distribute this first and you multiply by this, you get the same thing. Yes. Yes. Ask again. Think. Ask your questions.
No, I think that's it.
Okay. Think. Could you call the answer? Start for